Well, it looks like we're going to plan B. Who wrote this on the board? You guys are sneaky, yeah? Because how many problems do we have to go over? Well, if it's only one or two, then maybe we don't have to go to plan B. No problems, we gotta go over. Oh. Okay, 5. 7B. The rest of you don't even know because you didn't do it. 5, 6, 7 then. Okay, I'm just curious. Wait, did we start the video? Yeah, we started the video. What about number 1? Everybody got number 1? Did you do it the hard way or the easy way? That's what I want to know. Where's your number 1? How many people did number 1 using the distance formula? So everybody did it the easy way then. Saito, Leon, Mari? Again, stare straight at that. Okay, go over to number 1. Okay, there's 2 ways of doing number 1. Okay, here's the long way. Write the equation of the set of points in the Cartesian plane such that the sum of the distances from these 2 fixed points is 18. Hey, isn't that the definition of an ellipse? Except, I draw the picture wrong. Hello. It's 2, -4. I want to get this on video, that's why. So these are the 2 foci. These are the 2 fixed points. And if this is a representative point, x, y, then this distance plus that distance is always equal to 18. So how do you find the distance from here to here? Square root of x minus 2 squared plus y minus 10 squared plus the distance from here to here is the square root of x minus 2 squared plus y plus 4 squared is equal to 18. This distance plus this distance is 18, right there. That's the answer right there. But now you gotta multiply it all out, get rid of the radicals, complete the square, put it in standard form. How many people did that? Not one person. Usually about 1/3 the class, but that's assuming they did their homework. So how many, okay, what if I put this problem on the quiz? How many people would do it this way then? Let's just do it that way. Because I know some of you didn't even do the homework. Okay, but can you see this a lot of algebra? You gotta move this on that side, square both sides. You're still gonna have a radical. So you isolate that radical, bring everything on this side, square both sides again, and then you gotta complete the square, put it in standard form. That's probably gonna take some of you like 10 minutes, and some of you still probably gonna get it wrong. So is there an easy way? Yes. You have to know that this is the definition of an ellipse, right? The sum of the distances from 2 fixed points is constant. These are the 2 foci. Therefore, the center is located halfway in between, where? 2, 3. And since the foci are like this, so this is an up and down ellipse. So you can write almost the whole equation already. Y minus 3 squared over a squared plus x minus 2 squared over b squared is equal to 1. And all you have to know is a and b, and the problem is done already. Yeah, well, Mr. Park, all I know is that the distance from the center to the focus is c, so all I know is c is 7. Yeah, but what about this 18? Okay, how do you know that? Because it's in the notes. Or we learned it last year. You know this constant? This is 2a. When you derive the equation of the ellipse, the constant is 2a, which is the length of the major axis, which is also the length of the string. What string? You gotta be joking. So if 2a is 18, that means a is 9. And if you know A and C, how do you figure out B? What's the equation you need to know for the ellipse? C squared is equal to A squared minus B squared. You got to know this. This is the most important equation for the whole thing. So 49 is equal to 81 minus B squared. That means B squared is 32. So, whoo, that's 32. A is 9, so A squared is 81. Bakooey! Finished. Now, isn't that a lot better than taking this equation, squaring both sides, and putting it in standard form? Yes, wait. I challenge you to do that. Didn't Mr. Takiisa, when he derived the equation last year, he went through this? You guys don't even know. Okay, next. Somebody said number 5. And then, which ones are we doing? Because we're just going to do problems till the class ends, because we're going to plan B already. Plan B, tonight's homework is to catch up. Because I'm not going to rush through the hyperbola and then you guys still going to be there. So sad. Hey, by the way, I saw next week I can't call you guys names next week. Yeah? So I can't say dumb and sad. You guys are horrible. Yeah, but what if it's the truth? Okay, so which one are we doing? Okay, 5. An ellipse has one focus at 2, 2, and the corresponding direction. Okay, so here's an ellipse. One focus is at 2, 2, and the corresponding directrix is x equals 17. So how did I know it was on that side and not this side? Yeah, because come on. If you have the other focus here, then the direction is going to be there. This directrix is to the right of that one. How are you going to put that one to the right of that? You know what I'm talking about? Okay. Okay, pay attention to this problem because this problem's on the test. Write the equation of the ellipse if the eccentricity is 1/2. Oh. The eccentricity is 1/2. What is eccentricity again? C over A is equal to 1/2. Does that mean C is 1 and A is 2 already? No, because it could be 2 over 4, it could be 5 over 10, we don't know. And if I'm me, I'm not going to mix 1 and 2 because the people who think it's 1 and 2 are going to get it correct. Okay, so I have one equation. I need another equation to solve, right? If you have 2 variables, you need 2 equations. So we need another equation with A's and C's in it so I can solve it. Well, here we go. Here's the center of the... Actually, if you can figure out the center of this ellipse, the problem is pretty much done. What is the distance from the center to the focus? C. What is the distance from the center to the directrix with an ellipse? A squared over C. Some of us don't even have that one down yet. Yeah? And what is this distance from 2 to 17? Rhymes with 15. If you're at 2 and you walk to 17, how far did you walk? Right minus left. Okay, now look at that picture I just drew. What equation can I write? This plus this equal that. C plus 15 is equal to A squared over C. Hey, I got 2 equations, 2 variables, and you just solved it. Okay, I'll solve it. Cross multiply here, so A equals 2C. Substitute it in there. So C plus 15 is equal to A squared, which is 4C squared over C, which is 4C. 3C equals 15. C equals 5. So if C is 5, what's A? 10. Now once you know C is 5, that means the distance from here to the center is 5. So if I go 5 to the left, where am I at? -3, 2. We got the center. You can write almost the whole equation now. So this is a left-right ellipse, so the x comes first. X plus 3 squared over A squared plus y minus 2 squared over B squared equals 1. Now, my suggestion to you is on the test and quiz, once you find the center, do this, because if you can't figure out A and B, at least I give you partial credit, because at least you're telling me you know how to write an equation of an ellipse. You know it's a left-right one because you're putting the A squared under the x's, right? Whereas if you don't write anything, this will be minus 8, right? Hey, but we already know A is 10, so what is this? 100. And if you know A and C, how do you figure out B? You use the equation here again. C squared equals A squared minus B squared. So C squared equals A squared minus B squared, so therefore B squared is 75, and there's your answer. Okay, this problem's on the test, I'll just tell you right now. But then I told you the number 1 was on today's quiz and all hell broke loose when I was collecting it. What the heck? Okay, next. 6. Didn't we talk about the Earth's orbit yesterday? Okay, here's the sun. When the Earth goes, I'm just going to exaggerate it, okay, but because it's more circular. Oh, that's ugly. You start again. Because the Earth's orbit around the sun is nearly circular, but I'm going to exaggerate it a bit so that you can kind of see. Okay, here's the sun at one focus. What's at the other focus? Nothing. What did period 6 say? Wait, what did you guys say? Mars, huh?
Nothing.
Yeah, that's what I'm talking about. Period 4 said the moon. What did period 6? They said Mercury. I guess that one makes the most sense because it's closer. Yeah. Anyway, here's the major axis. This is when the Earth is closest to the sun. Okay, what is that called? Did anybody look it up? Okay, I'll give you a hint. It's either called aphelion or perihelion. Okay, ap and peri. And then when it's farthest from the sun, how come Lum knew it in period 6? And when it's farthest from the sun, which one is that? Is that aphelion or perihelion? You guys know helion is sun, right? Helios. Okay, anyway, I'm giving you, it says the close, so this distance here is 9.14 times 10 to the 7. This distance here is 9.46 times 10 to the 7. So you know this distance and that distance. It says, what is the eccentricity of Earth's orbit? Yeah, anyway, didn't we figure it out? Didn't we do it on our thing yesterday? 0.0167 or something. Okay, so if you know the Earth's closest and farthest distance from the sun, how do you figure out eccentricity? Well, first of all, what is eccentricity? C over A. So somehow I gotta figure out what C and A is, knowing this distance and that distance. Okay, here's the center. C is the distance from the center to the focus. A is the distance from the center to the focus, right? That's A and that's C. Okay, I'm going to call this M for the closest distance from the sun. I'm going to call this N. Okay, you have the numbers there. I just don't want to write all those numbers down. What equation can I write? Because M and M you know, right? N plus N is equal to 2A, right? Isn't M plus N equal to the length of the major axis? Which is 2A. So we know M plus N is equal to 2A. So A equals M plus N over 2. Okay, now how do I figure out C? Oh, okay, maybe we should draw this one here. Okay, wait. If this, oh boy, look at the picture. This is geometry. What? Look, if this is A and that's C, wouldn't this part here be C minus A? No, it's A minus C, fool. What, look, write an equation. Oh my gosh, look, this is A minus, this is C. Isn't this also A minus C over here? Oh, we got it already. What is, look at that picture, what can you write? It's geometry, look at that picture. Okay, we're not doing anything together. Look at that picture. I need another equation that involves C. So I can go C over A. A plus C what? Okay, very good. A plus C equals what? N. Okay, that's correct. A plus C is M. Oh, and A minus C is M then. Okay, but we gotta figure out C over A. Oh gosh. Okay, there's lots of, okay, no, we're gonna do it the long way. Okay, we already got what A is. How do I figure out what C is? So look at these two equations. No, we're gonna do it the long way. If I want to get rid of the A, what do I do? You subtract, so 2C equals n minus m. C equals n minus m over 2. So tell me, what is C over A then? If this is C, n minus m over 2, what is A? N plus m over 2. Multiply top and bottom by 2, you get n minus m all over n plus m. There you go. That's how you compute the eccentricity. So n is the farthest distance from the sun, m is the closest distance. So you just subtract the two numbers and divide that by, add the two numbers, and that's your answer. Can you see that you don't need a calculator for that either? Oh gosh. Oh my word. Next! Come on. Did somebody say 7?
Yeah.
What? Okay, did we do a problem like this on the parabola worksheet? Yes. Okay, it says identify the conic. Now, I don't even know if you guys even did the parabola homework. If you have something written in general form like this with the xy term, how do you identify what the conic is? You cannot just use the rules that we learned before now. Once you add the xy term in, it changes everything. What determines what kind of conic section it is? It's in the notes. B squared minus 4AC. So what is B squared minus 4AC? What does that come out to? 16 minus 20 is negative 4. If B squared minus 4AC comes out negative, it's an ellipse. Duh, this is an ellipse worksheet, right? If it comes out 0 like it did yesterday, it's a parabola. And then tonight's homework, which is going to be Tuesday next homework, if it's positive, it's a hyperbola. You know how I know that? It's in the notes. Okay, next, solve for y. Okay, how did you solve for y when you did the parabola? You put it in quadratic form, like this. We did this in the first quarter too. You put it in quadratic form and then you use the quadratic formula. Okay, there's only one y squared term. What's the coefficient? 1. There's two y terms, this one and this one here. This and this. What's the coefficient of y going to be? Negative 4x minus 2. Everything else doesn't have a y in it, so 5x squared plus 2x minus 7. Throw that into the quadratic formula. Y equals negative b. I'm not going to simplify it, you are. Plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to even multiply by 1. You guys do that. Okay, simplify this. Graph it on your calculator. Y1 is the one with the plus sign. Y2 is the one with the minus sign. Now what's going to happen is the calculator is going to graph it. So the one with the plus sign, I don't know how it looks like. It's going to graph the upper half of the ellipse. The one with the minus sign graphs the lower half of the ellipse. You put them all together, you get the whole ellipse. Now I don't know which way it's tilting. You guys got to get it on your calculator and draw it on paper. You don't draw it on your paper, it's wrong. So I'm not sure what that tilt angle is. You have to figure it out. Well, I can actually do this. A over A minus A. A over A. Oh! A over A minus C. The tilt angle is, what's half of 135? 67.5. It's 67.5 degrees then. I just did it in my head. So it's something like that then. Woohoo! Yeah, but you can't just draw this. You got to draw it accurately on your paper now. And then number 8. Did you guys do the secret I taught you? Of course not. Okay, we got time to do this. You guys, I don't know what to do. Now, if we're going to plan B Tuesday, if I walk around, this thing better be completed now. Okay, how did I tell you how to graph conic sections? Remember? Quadrantal angles. Okay, plug in 0. Go. 0. 2. Pi over 2. Pi. I'm just going to sit here quietly. 3 pi over 2. This is, look, you plot the formula. Remember the parabola one of the points was undefined? So that's why, but ellipse you got 4. Can you see the ellipse? Can you see it? Look. What are we trying to find in this problem? It says find the foci and the directrices. Now what did I tell you? What was the secret? One focus is always at the origin, always. So here's the focus right there. That's one focus. And look, if you gotta go 2 that way, you gotta go 2 that way to get to the other focus. So doesn't that mean the center is right there? What's the center? -2, 0. So here are the 2 foci. Yeah, okay, you guys have the answers on the bottom. Okay, now, what about the directrices though? How do I figure out the direct? How far is it from the center to the directrix? A squared over C. Yeah, but Mr. Park, I don't know what that is. Yes, you do, Moose Bread. A is the distance from the center to the vertex. Look, what is this distance from here to here? Count. 4. So it's 4 squared. C is the distance from the center to the focus. 2. That's 8. So to get to the directrix, you just got to go 8 right and 8 left. Boom. So look, if you go 8 right, where are you going to be? So 1. You want to draw it accurately? Okay, there. X equals 6. If you go 8 to the left, where are you going to be? -10. So 6, 7, 8, 9, 10. Wow! There you go. Isn't that a lot easier than changing this to a rectangular equation, putting it in standard form, and doing all that junk? If you, I'm telling you right now, if you know one focus is at the origin, it makes life so much easier. What about number 4? We didn't do number 4. What about number 3? We didn't do number 3. That's okay. You guys better get on it. Just imagine if we have to learn the hyperbola today. You guys will be in trouble. The hyperbola is the hardest one. And who's absent today? Nakayama. You guys better appreciate this. Nakayama, you heard me? Plan B.